I hope you all are safe and your loved ones are also safe and you're also following the best practices recommended by the medical authorities when you're traveling outside and uh, doing your day-to-day affairs. Before we move on, may I know whether my microphone is audible to everybody? Can a couple of you confirm, please?
Yes, sir.
Thank you. Great. Okay. So we are with the third session today, continuing our long discussion on the business mathematics and statistics. Um, I hope you could recall that we finished the lesson number one last week. Uh, we had two lectures in the first lesson. If I may just quickly uh, show you where we are heading. We just completed the first area on introduction to data collection, and extensively last week we discussed on the sampling methods. And today we are covering lesson number 2 out of the 11 EMR subject areas. That is on the presenting of data. This is a very straightforward lesson. We won't spend more than one day with the today's discussion and the lecture slides. We are done with this. And from lecture number 3, 4, and 5 onwards, we are going deep into the statistics, categorically the numerical computational statistics from lecture number 3 onwards. That means from next week onwards. If I just quickly fast forward a little bit and show you where we are heading, from lesson number 3, you will get a brief understanding on to what the central tendency measures like mean, median, mode, for instance, variance and standard deviation, what sort of concept is meant by the word normal distribution, standard normal distribution, where you can see those in the real world, and in some instances, why standard normal distributions are not always visible. For instance, if you take something like A-level marks of a particular batch of students, sometimes you may not see a nice normal distribution, rather a different one. So probably area number 3, we will be discussing very deep into those subject areas. Subject area 4 is also very interesting, and you'll be getting plenty of questions from these areas, maybe categorically 20 mark questions. That is on the probability, where you will learn the concept on what sort of theories is meant by the set theory, some basic introduction to probabilistic concept, what probability is all about, and how to resolve probabilistic questions using the equations and graphical methods also. And probably when we're done with the first 5 areas, you will be in a comfortable position to answer around 50, maybe 40 to 50% of your past paper examination questions. So likewise, we are continuing in each of these sessions. We are trying our level best to cover at least maybe 2 or 3 past paper questions then and there. So you'll be in a very comfortable position to understand what we are learning and how it is being tested in your examination. So I don't want to keep till the last moment and do a heap of questions where you may have forgotten certain theories. So rather, we will continue our practice on 1.5 hours of theory and followed with maybe 20 to 30 minutes of question discussion. But don't worry, hopefully, if things perfectly happens as we are planning, we will be left with at least 1 or 2 classes where you will be in a very comfortable position to discuss a lengthy past paper. Maybe we will do a mock examination also towards the latter part, where you will be in a real world 3-hour examination session, and I should be able to give you a feedback on where you can improve your writing at the examination. Okay. So that's on the first 50% of the lesson areas. I mean, we can keep on discussing on the latter part, but probably we'll spend time on the today's lecture. So um, as I always do prior to conducting this week's class, I always love to spend at least 3 to 5 minutes with you and quickly recap what we have done last week. I know that the recorded lecture is still available with you, but since we are continuing our discussion from a step-by-step approach, it's always important to know what we covered last week and where we are headed. Okay. This is on the last week lecture. I just want to quickly have a brief discussion on the content slides only, not more than that. I think we discuss on the importance of sample. The simple N is the denotation that we give for the sample, and the capital N is the word for the population. And there we extensively understood that there are two types of broader sampling methodologies available in the world, namely non-probabilistic and probabilistic sampling. So when you essentially do not know information about your entire population, you can use the non-probabilistic methods. And when you know a wide range of knowledge about your population, that is where the probabilistic sampling comes into play. So the non-probabilistic are pretty much very biased. So as the names are sounding, convenience, judgmental, quota, snowball. I mean, those are always, it's either the researcher's perspective or it's sort of like evolving from one stage to another, like a snowball, or giving a quota, or based on the judgment of the researcher, or the ease of access, things like that. But when we are discussing the other side of the coin, the probabilistic sampling, that is where you are trying to give an equal opportunity for the individual elements in your population to be selected to the sample. You're trying. You may not give a perfect representation, but you're trying. So simple random is the most widely used one. So you give some sort of a numbering for the items in your population, and then by using a random number table or a random number generator, you can pick few elements to your sample. Systematic is again, you try to put everything in a nice order and then do a systemic selection. Stratified, cluster, quota, these three are pretty much having very thin margins in the definition. But when you look at it, it's always you're trying to create groups, and from these groups, selecting items. Stratified is nothing but you the individual groups the same probability to be selected. Cluster, instead of selecting items from different stratums, you have multiple clusters like 300 villages, like 200 electorals, likewise. So out of that, you select 10 or 20. That's the idea of cluster. But quota, again, I want to stress the fact that quota and stratified are very much in line with life. But quota and stratified, the main difference is nothing but under quota is the researcher's perspective or the researcher's choice to give the quota. But under the stratified and cluster, it's not like that. We give the probability to play the role and give the selection. And then we discuss some widely non-probabilistic, some possible issues with sampling like measurement error, representative error. So those are pretty much theories. I don't want to stress more time. You just keep in mind of the essential line that I have put in the slides. That's the essence, or rather the extreme summary version that you need to keep in mind to answer the questions. But nevertheless, you should understand the fact that uh, the examiner's appetite towards testing are these not on the aspect of just writing one line, but rather elaborating, giving similarities and differences, sometimes doing a lengthy description. So make sure you put up plenty of examples, some definitions and some explanation and your opinion that will give you comfortable marks. Okay. So we finished discussing few past paper questions also on sampling, and that was the essence of what we covered last week. Okay. With that continuation, let me take you to today's lecture slides. We are here today with lesson number 2, lecture number 1. I mean, this is all. You only have one lecture for this lesson. This is on presenting data. We are going to discuss frequency tables and charts under this subject area. Okay. So what we have learned so far, we went through understanding what data is all about, primary data, secondary data, and then types of data. Then we understood that data in the real world sometimes can be very large, extensive. So you don't necessarily get a chance to talk to individual data point and get what you need. You all are researchers. So you are in the point of view of an like a statistician tries to come up with a concept or take a decision or do some analysis for your managers or for your next level seniors to make a decision. So from researchers' point of view, if you look at the lesson 1, what we have covered so far is on the identification of data. That's it. We haven't gone to the level of discussing the probabilistic aspect of it, discussing the variables, nothing on the central tendency or the nature of the data. We are still slowly identifying what this whole heap of data is about. Now, this section, lesson number 2, is very important for you to get an understanding of how are you going to present this data in a visual appealing manner. I repeat the line, visual appealing manner. If you could recall our very first discussion, that was on that 70 students case where we had uh, some students virtually in a classroom. So I need to assess the ordinary level mathematics knowledge of these students. Do you remember that? So instead of talking to all the 70 chaps, I just managed to put up a small sheet, collect some pass rates anonymously, and then summarize them, and then present it in a nice table or a chart. So this is where we are. The holistic idea is that if I just collect some raw data and present it in the raw form of it, the decision maker or the researcher will not get the essence of the, the dispersion of the data set. If you just write them in a raw form in an A4 sheet, you will be left with nothing but numbers or letters or words. But when you really want to summarize them and present it in a nice manner, today's lesson is going to tell you the different methodologies that you can do this job. But bear in mind that we today living in a world of computers, we do not necessarily do this by piece of papers anymore. We have like widely used tools like Microsoft Office package or open source Office packages where you can comfortably use Excel, Microsoft Word kind of software for you to easily give a set of table of data and create whatever you want. And even though those softwares are very much advanced such that now when you give the data, you can get some recommended presentations also. But why we are learning this is one is to, every electronicized way, you need to understand to do the manual method, for instance, when you do not have the electronic devices at your disposal. And the second thing is to identify the theory behind this summarization and presenting, so that you should be able to understand if at all your data set is being manipulated or window dressed or presented in a way that you might not get the real sense of it. That's the whole idea. And when we move to the last area on the today's discussion, on the discussion of past papers, you will understand that this area will give you plenty of free marks, where as long as you know what to be presented and what type of charts or graphs to be presented or tables, it's an easy manner to get maybe 5 to 10 marks in a question paper. Bear in mind the fact that 5-10 marks means a lot when you just merely consider the pass mark. I don't want you to stop at there, but rather go for your level best. So having that understanding, this is what we are going to cover today. First, we will understand the different historical methods of presenting data, array of diagrams, 10-well leaf diagrams. Those are some historical methods. Then we'll move on to what is called by the frequency tables. When you have large number of data points, it's easy to tabulate them and write the frequency. How many items are there in the table? Lastly, we will discuss some nice different types of charts. It's important to know the names of these charts also, because at one point, examination questions may suggest to, uh, you know, uh, draw a pie chart or a percentage component chart or a bar chart. Then the only difference between now and then is that as long as if you do not know the correct name, you cannot score the marks at the examination. Okay. That's about it. It's a theoretical lesson, nothing on the numbers. Just sit and listen, and when you come to the examination question, let's see what sort of angles is necessary for you to answer the questions. Okay, right. So first, we need to understand why we need to present data. So it's nothing but organize and arrange the raw data which can be emerging from a survey or a study for analytical purposes or for decision making purposes. That's the whole idea of presenting data. Nothing but. So the methodologies that we can use to present this data, I have summarized here. The first two, the light gray color ones on array of data and stem and leaf diagrams are some historical. But still, uh, I mean, when you want to collect some data, these are very widely used methodologies when you're using a pen and a paper. Then we will be discussing the so-called frequency distributions. Now it's important to understand that I mentioned a word called standard normal distributions. Now all these advanced concepts are stemming from these frequency distributions. You have an item, a variable, which can take a value. So for that particular value, how many items are there in our observations? For example, I have item number, let's say 17 centimeters. I have 5. 19 centimeters. I have 11 items. Likewise, the frequency distribution is all about nothing but how many items are there in our observation set or in our distribution or in our basket of items. Okay? There we will learn what these groups and ungrouped frequency distribution is all about. So as the name sounding, the ungrouped frequency distribution seems to be like we are counting the element by element. But in contrast, when you have the group frequency distribution, it seems to be all about we are trying to identify some classes, class 1, class 2, likewise, and give the frequency related to that class itself. Why we do that, we will see down the line of the discussion. So under the group, again, we are covering relative, cumulative, and cumulative relative to get some different senses of idea on how this distribution has been evolved. So the very first data presentation method, the most raw form that we can name it as nothing but an array of data. So when organizing an unstructured data set, so for example, if you look at this small rectangular area here, you will see nothing but numbers, 12, 20, 15, 10, again some 5s. So this is a perfect unstructured set of data set. Okay. Okay, sorry about that. So this is nothing but a perfectly spread of unstructured data set. But when you look at the bottom rectangle area, what I have done is I have arranged them in nothing but an ascending order. So out of these couple of 5s here, I can see 2 number 5s here. I will just put this to the very first items in this data set. Then couple of number 8s are dispersed here and there. I put them here. So all what I have done is I have arranged them in a ascending manner. Or you can do the same thing in a descending manner also. So you have 25 first, 24 second, 23, 22, 221s in an order from left to right. So when you just put this raw form of bucket of data into an ascending order, that's the whole presenting that we want to discuss here, array of data. That's it. We are done with it. So why do we do this? So for instance, if you are looking at maybe 20 to 30 items, it's perfectly fine to put them in a visual ascending manner where your eyes will be able to easily understand what the data set is all about. What the lowest value, the maximum value, approximately what's the mean value. Sort of like we call it eyeballing or visually inspecting. But when you have multiple items, maybe let's say, sorry, not multiple is not the correct word, maybe huge number of items, maybe hundreds, 200s and 300s, maybe thousands, then this is going to be a troublesome way to represent data. Let's discuss some advantages and disadvantages. The very first advantage is it's easy to identify the minimum and maximum values. How do you do that? You look at the very left hand corner, you have the minimum value. The most right hand corner, the maximum value, provided you have them in a ascending order. And these mode, median, range, these are some of the items that we are going to discuss under lecture number 3. These are sometimes called the central tendency and dispersion. These are nothing but representers, sort of like identifiers for your data set. Mode in statistics, we call it the most frequently occurring item. For instance, if you just look at this data set, I can see number 15 has been repeated multiple times. And that seems to be the highest frequency. So I can nominate 15 as the mode of this data set. Median is also another widely used uh, identifier or a ID for the data set. It's nothing but when you organize an items, let's say I have 5 items, then the third item which comes to the middle is the median. Range is nothing but the difference between the maximum value and the minimum value. For instance, if I discuss just the range, what's the range of this data set? This is 25 minus 5. That means 20 is my range. That means from 5 to 5 plus 20 number of items would be there in my variable set. That means 25, 5 plus 20, 25. So the 20 is the value that we can identify as range. Don't worry, we are discussing extensively this on lecture number 3. The whole idea is that you can easily visually identify them. Just a matter of putting them in an array. Finally, data is being kept in the original form. We do not tabulate them. We do not draw a pie chart and represent them. So that data as it is, you can understand what the numbers is going to tell you. The greatest disadvantage is the one that I discussed, maybe 300,000, 2,000. It's very difficult to get a sense of just looking at a bulk of numbers. Repetition. Now this 15 is being repeated maybe 1, 2, 3, 6 times. That doesn't make really sense when it comes to the decision making. But as long as if someone can say I have 6 number of 15s and 3 number of 20s, that's more useful than visually just trying to count this. Finally, this is not an effective summarization of data. But all in all, why do we use this array of data? Sometimes when you really want to, collect a data set in a raw manner, this is what you get in a system or a survey or a collection. Let's say you're standing on a road and trying to calculate the number of cars that is passing by, cars, lorries, and vans and bicycles. So this is one of the methods that you're going to collect data and then try to go to the next levels. Okay. So this array of data, these are not very questionable things in the examination, but this is the very legacy, very first building block of presenting data. Okay. The second one I want to discuss is the stem and leaf diagram. So this is in Sinhala, I remember we call this as Vrunta Patra Satana. Vrunta Patra Satana. So it's sort of like a stem of a particular leaf which is being binded to a tree. So the stem is going to tell you where this data is going to emerge, and the leaf will tell you the last value of a particular data set. Okay. This is the visual representation of a stem and leaf diagram. We'll come to advantages and disadvantages in a little while. If you look at this data set, you have 150, 567, so on and so forth. Now, in the raw form of these numbers, you may see that it is consisting of 3 digits in this raw form. But if you really look at the repetition elements, you could see this 145, 141, 148. Now all these items has this 140 in front. So the stem will consist of 1, 4 in that case. And the leaf is going to tell you the last digit of a particular number. Let's say this is 1431. Then 1, 4, 3 is going to be your stem and 1 is going to be your leaf. Leaf always represent with the last number. So once we do this, this is a first step of summarization when we are coming from an array of data. When you look at it, rather trying to look it in that rectangular area filled with numbers, Here, you can forget about the stem and just focus on the leaves and see what sort of a distribution is all about. And if a particular number is repeated couple of times, or if a particular line, let's say in here you may see the most number of occurrences is with 140s, the second is 160s, and the least is 170s. So likewise, you are getting a bit more sensible understanding to the distribution. Lastly, I want to highlight is that always when you do a stem and leaf diagram, it's best practice to write the key at the last part of it so that the viewers won't get multiple definitions to your diagram. So although we call it a diagram, finally the output is going to be nothing but a nice table like this. We'll see some of the advantages and disadvantages. So like the previous method on array of data, it's easy to identify the minimum and maximum values. Easily you can scroll here and see this is the minimum value and this is the maximum value. So compared to this raw form of data set, when you represent it in this nice stem and leaf manner, it's easy to always identify the min max value. Mode, median, and range, similar argument. This quartiles is also another representation of data set. Now, quartiles is nothing but the 0, 25, 50, 75, and 100 position of a particular data set. Okay. So quickly, since the bird came, let me just quickly try to give you a sense here. Quartiles are nothing but when you have a data set like this. So we have the minimum point here. This is going to be your median or the 50% mark. So when you come from here to here, you are covering approximately 50% of your data set. And this is the 100 point. So these points, 25th and 75th, now these are the quartiles that I'm going to discuss here. In statistics, sometimes we call this as the Q1, first quartile, this is as Q2, and this one as Q3. Sometimes in statistics, we use some special names like interquartile range for this Q3 minus Q1. This is all about trying to understand what is the concentration of a particular data set. Sometimes you may see that data towards this end, data towards this end, the hundreds ends are much more having lesser frequencies. And here, under the median and the range of 75th to 25th, you may see much more concentration. So when you put your data set in a stem and leaf diagram, what I just want to mean here is that it's pretty easy to understand where the 25th and 75th is going to be lie on roughly, not statistically, but roughly. Okay, that's the whole idea. Right. Fourth advantage is visibility of the data pattern. Visibility is nothing but you can visually identify how the actual data is being light on. We haven't gone to the charts and graphs yet. Still, we are playing with the raw data. Two disadvantages that we can discuss broadly is that the very first one is on the bulk of data. The moment the first two legacy methods are being discussed, stem and leaf and the array of data, keep in mind that these are very not practical in the case of a bulk of data, thousands of, 10,000s of data. These are not the best methods to be followed. And also, again, there's no summarization, rather, we are still playing with the raw numbers and presenting again them in a very much raw manner. Okay. Right. So, finishing our discussion on the legacy methods, let's move on to the modern statistical methods that we represent this collected collected data. Okay. So when we are starting our discussion on the frequency tables, I thought of just putting up this slide for you to give a glimpse of what a perfect table is all about. This is sometimes students, I see a lot of youngsters like you tend to do not give so much attention when you really do a table, both maybe at your professional and examination aspects. So I implore and I advise always when you are trying to continue your studies, always try to keep this slide in your mind and never forget what is mentioned here. This is piece of professional advice rather examination aspect practice. The very first thing is whenever you do a table, the best thing is to refer it by a table number. Look at the table that I have put it on your right hand side. I call this table as table 3. So whenever you want to, I mean, why do we give this table a number is that it's easy to refer back, isn't it? So if you want to say, if you want to put this table number 3 down the line of an article or an answer and then move to maybe 1 or 2 pages, and then obviously you have to talk back to this table number 3 at one point. So rather you write some various description onto that table, this table. It's always easy to mention table number 3. Second aspect is that you have to put a respective topic. Uh, let's say population of Sri Lanka based on different provinces. So try to make it very concise. Try to limit the number of words because we are talking about a smaller space. So rather you write a very lengthy narration like a small para, maybe use a couple of words and put up a respective topic. 3. Titles for columns and subcolumns. This is very important. Even if you look at the very first column, I've just put this number sign just to indicate that this is the number of items that I'm preparing. Yeah, or if you put NU or N or N or number, that's perfectly fine. And look at the other columns, I have put the respective names. And this is the most important uh, advice here, the units. You may have, I mean, down the line of you writing an explanation or an answer or an analysis or a paper, down the line, you may drill down your mind to the units of what you are presenting. But for your viewer or for your examiner, he or she may doesn't know what the units that you are really representing. And if at all, your range of data units would vary from ones and hundreds and maybe to millions, obviously you are at a greater disadvantage because you may uh, accidentally put the similar style of units to multiple tables and that will give you a completely distorted answer. So always put the units. Even let's say you are presenting the raw numbers in brackets, you can say units. That gives a viewer a sense. Okay, this has nothing to do with any decimals or thousands or millions, but I'm looking at a raw number. Okay, that's the most important. Totaling and subtotaling is also very important. If you look at a balance sheet or income statement of a company, just go to the Colombo Stock Exchange, go to any company, go to quarterlies and try to download it and see. You will see how organized those numbers are. And importantly, if you look at an item like a balance sheet, you may have some current assets, fixed assets, then the total, maybe 2 column totals, maybe 3 column totals. It's always important to, whenever you put up a table, put up a subtotaling and final totaling. Okay. Last couple of advices is on whenever you have a source to be put up here, obviously at the examination you don't have any sources. You are answering the examination furnished scenarios, but rather at professional aspects when you are referring to a particular source, always in small fonts put up the source. And also if at all you have any more explanations, put up an asterisk or a particular sign and put up a footnote wherever. Okay. So moving forward, these are sort of like guidelines for you to never forget. But if you look at some practical aspects, I mean, when you are putting up a couple of tables in your examination paper, you don't necessarily start from table number 1 and end at table number 17, that doesn't give you any sense because the examiner will look at different questions in different patterns. So be mindful of certain these recommendations will not be always applicable for the examination. Okay? Keep in mind. So that's on the characteristics of a perfect table. So with that introduction, we'll see what this frequency table are. Tables are both grouped and ungrouped. Okay. This I don't want to spend more time. The moment you are going to tabulate it, this is all about the answers to the stem and leaf diagram and the array of data. It's easy to compare, repetitions are gone, easy to navigate, visually see what the ranges are, and you can clearly identify differences between some points. So these are all advantages. These will be not questionable, but just to mention that why we are moving to table from the classical representation methods. Okay, right. The first style of tables that we can discuss under the data representation is the ungrouped frequency distribution. If we quickly jump to the blue color table here, what we see is you have the data set, that's 11, 12, 10, again, some few numbers being repeated here and there. What I have done is, under observation 10, I have put frequency as 5. What do you mean by this frequency? Nothing but the number of items or number of occurrences. Okay. If you look at observation 11, you have 3. You have the first one here, second one here, third one here. Collected them and put the frequency. This is one of the easiest way to summarize a raw set of data. We call this as, in professional statistics language, we call this as an ungrouped frequency distribution. It's important for you to know the name. Okay. This is a table which organizes a set of observations based on their occurrence or frequency. Occurrence, number of items, frequency, all are synonyms. It's quite useful when large number of data are evident. So when you have hundreds or thousands of data, this is one of the obvious easy way to represent a data set in a table. So under each observation, we have given one line item. Under item number 11, item number 12, and item number 10, we have given 3. So what if you have, let's say, 300 or 400 number of observations? So obviously, still this is not going to be an optimistic method. Under the next grouped frequency distribution, the answer is there. But still, bear in mind that so if you're talking about maybe 10, 15, 20, 30 kind of a number of observations, this is very handy and it's visually appealing for anybody to see and understand the nature of the data set. Okay. This is the answer when you have a large range of data available in your observation or in your data set. Okay. So the difference between this and this table and the table we are discussing right now is nothing but, instead of individual numbers, instead of number 10, 11, and 12, we are going to introduce classes. Classes. Okay. So classes are nothing but the range of another data set. So here you may see data from 24, 21, 17, 11. So if you look at the individual frequency occurrences, sometimes you may see 11, 1, 10, 1, 13, 2 items, 17, 1 item. So if you just put them in a individual ungrouped frequency distributions, still it may be pretty much similar to what your real raw data form is all about. You will write about maybe, let's say I can eyeball and see around 12 data elements are there, maybe around 7 or 8 data points you will still have to identify as ungrouped frequencies. But coming to the classes, nicely I have sliced them into 3 classes: 10 to 14, 15 to 19, and 20 to 24. So under this method, It's very easy to classify the data and put them in a class and call it as the class frequency or the group frequency. So the 10 to 14 frequency number 5 means there seems to be 5 items in the class of 10 to 14. But where exactly these items are going to occur, that doesn't, this style of frequency distributions is not going to give the answer. But it is very handy when you are dealing with a large number of data sets. Okay. So even here, we are still looking at a range of maybe 11 or 10 or maybe 14. But still, if you look at a data set of maybe starting from 1 and range into 2000 or 3000, now those are the classic example of group frequency distributions are going to be very useful. Okay. So the whole idea, text doesn't really matter here. The whole idea is that we are going to introduce classes to the discussion right now. Right. The first step, these are the steps that you're going to follow when you're going to do a group frequency distribution. The first step would be to determine the size of a class. Now here, if you look at the, sorry, if you look at these classes, you may see I have done the intervals of four items for individual class B. 10, 11, 13, and 14 is going to be the width of my first class. 4 is the range that I have given for the class. And 15, 16, 17, and 18. Again, another 4. 20 to 24, again, another 4. That is what is meant by the size of the class. So, the best practice would be to treat the classes with an equal range. The smaller range of a class interval to be equal. Why? So it's very easy to compare. If you have a distribution of, it's not wrong to represent, by the way, but if you represent from 0 to 20 and then 20 to 22, 22 to 25, and then 25 to 75, likewise in a different size of classes, your output is going to be very much distorted. It's not going to be very useful. People won't get an understanding as to how your data are dispersed, but rather when you nicely discuss your data set with a similar width of a class, it's very easy to understand the frequency and the dispersion, the nature of the data, how it is being distributed. Okay. So once you determine the size of a class, uh, you can analyze the range of the data set and then divide it by the number of classes that you are going to anticipate. Look at this example. Sorry, not the example. Let's say you have a range of uh, 20, 0 to 20 are the uh, number of values that can take for your variable. Okay. You're going to determine my class width is going to be 4. That means easily you can divide 20 by 4 and eventually you can judge that I am going to discuss my data set with the 5 class interval. 5 is going to be the number of classes and 4 is going to be the range of a smaller class. Okay. Let's say your data set is going to range from 100 to 10,000. 100 to 10,000 is the data range. You're kind of clueless. You don't necessarily know what the class interval is going to be all about. Point number 3 is suggesting it's always a good practice to have a minimum of at least 5 classes and maximum of around 20 classes for a fair representation. If you have more than maybe 20 or 30, then again your class representation is going to be similar to that ungrouped frequency distribution that we talked about. Individual items, individual frequencies. When your number of classes are very much larger, maybe 30, 40, 50, again, your representation is not going to be a summarization, rather sort of like in row form. So always try to follow this best practice. Maybe 5 to 20 is going to be a good number for a fair representation for a group frequency distribution. Okay. So there are different types of group frequency distribution that we are going to discuss next. Okay. Excuse me. 1 minute. first style of this representation is called as relative frequency distribution. Okay. Forget about the definition. We'll see what this table is going to tell you all about. 10 to 14 up until 20 to 24, the similar frequency example we are going to discuss. This sign is called sigma, or this is used to tell you the total, sort of like a shortcut. Sorry, a synonym rather. So 12 is the total frequency of this data set. That means you have 12 elements in this data set. So the relative frequency is nothing but representing what's the share or the percentage of this individual class in compared with the total frequency. It's very easy. If you look at this class, for example, 10 to 14, you have 5 items as a frequency out of a total of 12. So 5 divided by 12 is the relative frequency of this particular class. Look at the next class. 3 items out of 12 is the relative frequency. So if you sum this area also up, you have to get a value of 1. 12 divided by 12 is going to be 1 or 100. Okay. So the whole idea of this term relative frequency is going to give you a sense of a percentage. This is nothing but giving a percentage value for the individual class. What sort of percentage is being assigned for individual classes based on the frequency of items occurring. Okay. Don't forget the fact that this 5 means not the number 5, but there are 5 values, maybe 10, 11, 12, 14, another 10, which is in this class. Okay. And the total number of items are nothing but 12. Okay. So the whole idea is again percentage of total frequency. As a percentage of total frequency, when you do that, we call it the relative frequency distribution. Okay. Moving on, another style of this frequency distribution that we can discuss is named as cumulative frequency distribution. Cumulative, the word uh, sounds a bit strange, but the idea of word cumulative is nothing but what is the total up to now? What is the total up to now? Okay, let's say from class 10 to 14, you have 5 items. Okay. And 15 to 19, you have 3 items. But when you're going to discuss the cumulative frequency for this second class, instead of 3, you're going to tell it as 8. 5 plus 3 as 8 cumulative frequency. Moving on to the third class, individual frequency is 4. Here you are going to tell the cumulative frequency as 12. So the idea of word cumulative is nothing but adding the individual frequencies of the classes up until the class that we are discussing under. Why do we do that? So it's easy to understand what's the number of items that are included in this particular class and below this particular class. Cumulative frequency can be discussed from both sides, from 0 to 100 and 100 to 0. Both sides we can discuss. We have some examples also, don't worry. The first step would be to determine the real limit of each classes. Now, when you really want to limit these numbers. So, for instance, if you look at this numerical values of 14 and 15, you may see there are still some numbers which could be uncalculated. Now, this example that we are discussing doesn't really have numbers of decimals, but the practice is always you have to identify, or although there are class intervals is being represented with these whole numbers, still you have to identify the real limits in cases where there are decimal numbers could be available for these classes to be assigned later. So instead of 10, this range is going to be 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5. The moment we put these numbers, the question which can come to your mind is where the 14.5 or the 19.5 value is going to be calculated. Is it going to be under the first class or is it going to be under the second class? There's an answer in the next couple of slides. Don't worry, we'll come to that. But before that, I want to stress the fact that usually we have to assume two similar classes for both end with a frequency of 0. What do you mean by this? So from 10 to 14, okay, we said the class interval, the real limits are going to be 9.5 to 14.5. That we can guess. But for the values below 10, it's an assumption. There are no classes, but there are no items to be observed. But for the completeness of this table, we have to assume a class of similar size, both ends, not only from 10 to 5, but also from 24 to 29. Similar class widths, we have to assume that there are two classes. That's a perfect representation with a frequency of 0. Okay, so this is the first step of moving ahead with the cumulative frequency distribution. Then the point that we discussed a moment ago, 9.5, 14.5, where it is going to be like. There are two styles where you can present these cumulative frequencies. Namely, those are less than or greater than style. Okay. Look at the second bullet point. If a class represents values of less than from the upper limit, less than from the upper limit, highlighted in red here, of a particular class, such distributions are called less than cumulative frequency. That means a particular number, 9.5, is going to be belonging to the class number 1. 14.5 is going to be belonging to class number 2. 19.5 class number 3. Likewise. One could again argue, this doesn't really end here. I mean, even from 9.5 to 9.5, even if you try to stop it there, one could argue, what if 9.5000 another number comes? I mean, there's no end for a particular margin in real numbers for argument's sake. You may do the same exercise for 2 decimal points, 3 decimals. That's up to the data representing, depending on the number of decimal points in a particular class. Okay, let's say we're discussing temperature or some humidity kind of data. Yeah, there will be huge number of decimal places getting involved. But bear in mind, the example that we are going to discuss here is assuming that we have items with whole numbers. That means 11, 10, 12, 14, 17. Those are the numbers. We don't have decimal numbers on those values. But if you have a decimal engraved, obviously the best practice would be to go to a second decimal point and do the same exercise. So instead of 9.5, then you may have to discuss 9.55, maybe one further decimal point, likewise. The whole idea, just that we don't have to go to that far, but to get an understanding, if you really want to represent your data set in a less than or a greater than manner, that's all what we need to discuss and finish it off here. Okay. So this red color highlights that I have put in these real class limits are to give you a sense of, although there are some whole number margins here from 9 to 10, if at all the margin number comes up until 9.5, including 9.5 is going to be belonging to the less than class. So the flip side of this should be the greater than. But before we move on to that point, we'll see what this table is going to tell us. Okay. Now, I have this frequency 0. Now, this is the assumption that I made here. And because I don't have much space here, I haven't represented the last class interval, which is 24 to 29. But even if there is one, I could say this is also as 0. Okay. So this is just for the explanatory purposes. We don't have to really bother about this particular row. But discussing the data points on the second row onwards, what do we have here? The same representation of 10 to 14, the frequency of 5. Relative frequency we discussed a moment ago. What's the total number of frequency? That is 12 items. So 5 divided by 12 is the relative frequency for this class. 3 divided by 12, 4 divided by, now these are the relative frequencies. And when you look at the cumulative frequencies, this next column, watch carefully. The first is 5, that's fine. But the second is not 3 anymore, it's 8, 5 plus 3. The last is 12. This is the cumulative frequency for a particular considering class. For instance, cumulative frequency 8 in for this 15 to 19 is going to give an indication, okay, there are 8 items which is either included in this class or below this class. 12 items either included in this class or below this class. That's the whole idea of cumulative frequency. Okay. The cumulative related frequency is nothing but again, now from frequency we construct the relative frequency. How did we do that? We have the frequency totally here. But when you look at the cumulative frequency, sorry, the cumulative relative frequency is also nothing, very simple. We are doing the same exercise from the cumulative frequency column instead of the normal frequency column. So we start here, 5 divided by 12, 8 divided by 12, and 12 divided by 12. Now at this point, one could understand, okay, 100% of my data points are below this uh, particular class. Or 8 divided by 12, 75% of my data points are below this particular class. 5 divided by 12 is the cumulative relative frequency. So the whole idea is that from frequency, you can either define the relative frequency or cumulative frequency or cumulative relative frequency. To just keep in mind of the simple steps that you can write each of these items. Okay. So now this whole explanation is on the less than style, less than real limit style. The flip side of this is the lower than style. So exact similar explanation, but here we're going to say the bottom value is going to be belonging to the class beneath. So 9.5 now is going to belong to the class of first one, 14.5 to the second one, so on and so forth. Okay. Now, similarly, uh, the last line again, you don't have to worry. This is that line, as I said in the previous slide, which is going to be the 0 class. This is a similar interval class towards the top hand side. Okay. 5, 3, and 4, these frequencies are exact similar to what we have here, 5, 3, and 4. Okay. So here, the lower than, sorry, the greater than style is going to tell you whether a particular class will have a number of elements greater than this particular class point. So this relative frequency, no difference. 5 divided by 12, 3 divided by 12, and 4 divided by 12 are pretty much same. Now this cumulative frequency, instead of starting from 5, 8, and 12, now under the greater than style, if you are going to represent, you have to say 12 is my cumulative frequency from class number 10 onwards. That means you have to read it in a way that I have 12 items above and including this class of 10 to 14. Only 7 items including and above this class interval, and only 4 items including and above this class interval. Okay. This is the flip side. Previously, you're defining lower than or including the lower limit. Now here, greater than from the lower limit style. Look at the cumulative relative frequency. Now instead of we start previously with 5 divided by 12, 8 divided by 12, and 12 divided by 12. Now here, how do you read it as? You have 100% data points included or above this class. 7 divided by 12 percentage of data included or above this class, and 4 divided by 12 included or above. That's the representation. The takeaways are the keywords of relative frequency, and cumulative relative frequency. Keep in mind the style that you're going to represent, the greater than or lesser than, and make your explanation very clearly if at all you're using these group frequency distribution tables. Okay, right. With that, we are done with the discussion on the tables and elementary level of uh, array of data and stem and leaf diagrams. Third section, this is the real visual appearance of data representation comes into play. Visual, colors, patterns, and graphical forms are going to be used here. Okay. There are a few commonly used types of charts that will be based on the nature of data, purpose, presentation, etc. Okay. These are the three styles of charts that will be widely discussed and used, and even at the examinations also, you may see being clearly requested to be drawn upon at certain questions. First style, we call it as the bar charts. Simple bar charts, component, multiple, those are some widely used chart styles. Okay. Pie charts are very easy to visually identify as long as we see everything as a circle. So inside the circle, we could give some weighting for a particular number of items to be displayed. We know 360 is the allocation for a circle, and out of these 360s, from degrees point of view, each and every item will be represented. Easily, you may see like electoral results or some dispersion of a pandemic, like in what we see in these days. Pie chart will give you an understanding as to what sort of a percentage is being given more prominent compared to the others. Or even if you look at a revenue of a particular company, you may see a pie chart will be pretty much easy to visually see what's the maximum and what are the others. Yeah, in pie chart, sometimes you may see others as an explanation, maybe less than 5% of the data. You don't have to really give some allocation, but rather you classify them as others. So there are different styles. A scatter diagram is the only one that we'll be carrying forward from this lesson to an upcoming lesson. Why? Because then we need to do a bit of scatter diagrams and show you how we can move from this point to the normal distribution and then do the advanced calculation. But still we'll get a brief understanding onto what a scatter diagram is all about. Okay. So we'll spend some time here and try to understand the names. Categorically, students, important to understand the names, or sometimes you may get confused and draw a different chart which will not give you sufficient marking at the examination. So I know it's pretty back to basics and simple stuff, but still at least try to remember the names. That's more than sufficient for these entire slide set from this point on. Okay. Right. From the first style of charts we are going to discuss is the simple bar chart. This is a chart which will represent the value of a variable based on the height or the length of a bar. So we can broadly have two types: horizontal bar charts, vertical bar charts. We have some examples coming up. Important point, width should be equal in all bars. Now, similar to the class intervals that we discussed again and again moments ago, width has to be equal. I mean, it's no illegal to draw bar charts with different widths, but as long as your widths are equal, your data representation is going to be pretty much visually appealing. Sometimes, for let's say from 0 to 20, there are maybe very light number of items. So you may have a different class interval, but from 20 to 25, 25 to 30, you may have a huge number of items. So there are instances where your widths can be uh, not equal to each other. So that's perfectly fine. But wherever possible, it's important to have the widths to be equal. Unless otherwise, you have to clearly mention the widths under each of these instances. Otherwise, um, visually it could be some distorting. And gap also should be equal between all bars. So visually, a nice simple bar chart should be like this. These bars, when you're drawing, some lazy students sometimes at the examination we can see they just draw these bar charts in a very rush sometimes. So it's not really visually appealing. Provided that there are some comfortable marks to be allocated, have in mind that your graphical representation has to be very precise and very eye appealing. It's very important, eye appealing. Okay. Look at this data set. We have years here, 2015 to 2019, and units manufactured in thousands, 8,000, 10,000, 9,000, 12,000, and 7,000 is going to be my tabular. And now this form I am going to convert it to simple bar chart form to have a greater understanding compared to the one in the table. I mean, visually, of course, one could see, okay, 12,000 in 2018 seems to be the highest number. But if you just focus your eye to the right hand side and focus on the bar chart, it's much more easier to understand the maximum, minimum, and the pattern and the trend and all these things. Profits, budgets, balance or deficit kind of values are pretty much showcasing these values are pretty much very easy when you're using a bar chart. Sometimes people want to see the trend. Let's say now this is units manufactured. You could see from 2015 to 2018, although there are ups and downs, this seems to be moving in an upward trend. And from 2018 to 2019, there seems to be a dip. Now, with this, sometimes the next number, 2020, next predicting number is going to be a golden number. No one knows what is going to be. That may depend on various factors. So why do we visually represent this simple bar chart form is merely to uh, see the trend or the pattern or the historical performance. Uh, the next extension of this bar charts, which I don't really want to spend time on, is nothing but a line chart. A line chart would be nothing but putting, instead of a bar, putting up a small dot here or a cross here and joining these by a line. So a line chart and a simple bar chart, you don't see pretty much of a difference, but rather here you may see bars, and in a line chart this central point of a bar will be joined by a small line. Sometimes you may see a casual line, sometimes you may see a area being highlighted by a line. So pretty much a line chart and a bar chart are nothing but very much similar in the representation. Okay. Simple bar chart. The second form is the we call this as the vertical form. This is a horizontal form. Um, this is also pretty much similar, but sometimes now here, if you have negative numbers, you may have to have the bar chart representation in a pretty much of a uh, heightful manner or with a greater height. But if you flip, turn the chart by a 90 degrees, you will in a comfortable position to represent negative numbers. Look at these facts. These are profits. So 2018, you have made a loss. So from 2015 to 2019, this axis moves with time, and this x-axis moves with the profit amounts. So you may see profit has declined from 2015 to 2017, sort of like a declining trend, and in 2018, it has gone to a loss. And 2019 again, this company has rebounded its performance and sort of like catching up with the trend again. Okay, so these are two widely used patterns of bar charts, horizontal and vertical. Very easy to represent. One piece of advice is to uh, mark the units here. Try to put up axes also wherever applicable. Now, One style is you can put up an arrow here, and on close by to that arrow you can write units manufactured in thousands. Here also you can put up an arrow in the x-axis and write yes. That is one aspect. Or below these numbers, you can put up the representation. That's perfectly fine, up to you. And important thing is to have a small title for your chart and some color representation. Wherever applicable, put up small dashing lines for the viewer to easily identify the height. This bar charts is nothing but height representation of data. So your heights has to be perfect and to the crisp and the dot. Okay. So why do we still learn this? Bear in mind that when you see the examination questions, sometimes you may see that, okay, I'm talking about a, multivariant analysis or I'm talking about portfolio theory, but still 5 marks are being given for a simple representation of a chart or a graph. 5 marks, 5 whole marks. So that's why we are learning this and try to identify what these names are being given in the statistical jargon. Okay. Second style, we call it as a component bar chart. It's usual, so it's useful when we want to display the composition of multiple components of a given variable. So a given component, let's say assets, will be comprised of different components, current assets, fixed asset, likewise. So the variable will have a height, and inside that height there will be smaller components which will be given some different values. Either absolute values of a component or relative percentages can be displayed using a component bar chart. That means you can either say, okay, my assets comprise of 700 is my value, 200 from current assets and 500 from fixed assets. One is that angle. On the other hand, you could say 33% from current assets and 66% from fixed assets. That's also another possible way of identifying the component. Further, it's important to display the key depicting individual components. So, unlike these items where you are discussing one single aspect, now here, this bars is going to tell you the profits. Here, it's the number of units manufactured. But when you come to the component bar chart, now the height is going to tell you different elements. So, it's important to write a key or give colors or definitions to whatever you are drawing in this chart. Okay. See a couple of examples. This is a easy example of a component bar chart. What is in this x-axis is the years 2017, 2018, and 2019. We have the sales revenue of this company A distributed to Kalutara, Gampa, and Colombo districts. If you look at these numbers, 150 here, 250 coming from Gampa, and 200 coming from Colombo. Now, if you look at this key, this scaling, it's hundreds. I have selected carefully because my minimum value is 50. If I see 210 or 270, this keying or grading should be change in a way to maybe 25 or maybe tens or whichever the comfortable manner to be. But here it's easy. I have 50s as my minimum value. So whichever the point come in between 100 and 200, I know that's the end of 150. So the total of 600 for this particular Colombo district is being distributed by, 2017 of 600 coming from Colombo, Gampaha, and Kaltara likewise. So this is one form of doing a component bar chart. Okay. Why do we do this again? We have one variable, one single variable, that is a sales revenue. We want to identify the individual components contribution for our variable. 2017 company A sales revenue is 600, but that seems to be coming fairly from all these three districts. So we are happy with the lowest contribution coming from Kaltara. Then we are fine. 2018, it's expanded in a similar manner. But in 2019, if you look at carefully, majority has come from Gampaha district and a minority has come from 100. Each has come from Colombo and Kaltra. So visually, you can identify what has happened to the individual components of this particular variable. You can easily identify this blue shaded area is being kept pretty much same. It's 250 here, 250 here, and 200 here. Sorry, 300 here. But these other ones, the green ones and the purple ones, have given lesser contribution towards 2019 when coming from 2017. So easily, at a glance, when you look at this component bar chart, you can identify, okay, whether my individual components has given a greater advantage or a lesser advantage for my particular variable. Okay. So this is again, students, this is just a one style of component bar chart. The second style is the percentage component bar charts. So instead of these numbers being represented in the actual manner, this 600, this 800, and this 500 in this actual manner, we could do a 100% equi, how do I say it? 100% sort of like a mapping of these numbers. So how do you get this height for this Kalutara and Gampa and Colombo? It's pretty easy. Just take your calculators and see what is the total for this particular district in, sorry, for this 2017 year should be 600. So this height should be nothing but 150 divided by 600. This height should be nothing but 250 divided by 600. So previously we did not have such relative representation, but the actual as it is representation. But when you come here, sorry, the relative component bar charts, this is always 100% equate value to be represented. So every bar will be equal to 100. So that means just by looking at this graph, you can't identify the total value or the actual value or the exact number of sales revenue for these individuals, but rather you can, what you saw here in a very glimpse of what we discussed here, saying that Gampa seems to be having even much more contribution, is exactly visually very much appealing in this particular area. So these are nothing but the relative numbers of your exact components of your variable. For instance, if we discuss Kalutara in this blue color, first year 25%, second year 30%, and last year it has dropped to 20%. On this side also, you may see approximately 33% dropped to maybe another 31%, and it has dropped down to 20%. So what has happened? Dampa district seems to be giving much more sales revenue to the company A over time. There, when you just look at this percentage component bar chart, you could easily see, okay, Gampa seems to be on one aspect. Your decision maker can argue, okay, Gampa seems to be giving us more revenue. Fine, we can focus on Gampa. But on the other aspects, you can say we have to do something to Colombo and Kalutra districts to, get more percentage of revenue so that our absolute number will be larger and larger in the upcoming years. So both these styles, component bar charts and percentage component bar charts, will give you nothing but the dispersion of the individual variables components of an individual variables will be visually represented here. Right. Now these are pretty much simple. Multiple bar charts also representing this variable, but not like including in the same height, but rather in adjoining bars attached together. So this is pretty much an extension of the component bar chart. The component bar chart has the same height for a particular item, and inside that particular height we subdivide. But the multiple bar charts, this is sort of like visually pretty much you know trouble to see sometimes when you're using multiple colors. But for few, maybe two or three different items, sometimes compared to visually trying to see what these heights are, trying to see them in this manner would give you a great understanding as to what has happened to the individual variables. Okay. So look at this example. To represent tourist arrivals from India, Australia, and Germany during last 5 years. So I have only three countries, 5 years. So 15 items. So first, if I went through the component bar chart methodology, I will be left with 5 bars, and I will have to eyeball for India, Australia, and Germany under individual items. But here, if you use the multiple bar chart concept, it's pretty much easy. You can uh, tell your eye to focus on one color and look at what has happened, whether you can see an increase in trend or a decrease in trend. The simple example I've quoted here are imports and exports of a particular company in 2017, 18, and 19. So one could argue, okay, with imports, exports has also gone up. This could be a company or country, anything. So the only difference between this and the previous component style is instead of one bar, we have multiple bars. So the moment you have, let's say, multiple components of a particular variable, let's say you have 10 countries, this is not going to be a very much visually appealing manner to represent it. But because every year you have to draw 10 different bars. Now, when you have a key on your right hand side or the bottom, obviously you'll be using multiple colors. So it will be very much cumbersome for somebody to identify, okay, where India or where Australia is going to be. But instead, maybe two or three components, multiple bar charts are pretty much fine to uh, represent the data. Okay. Don't forget the facts. If you consistently look at my representation, I have the axis has been marked here, year, and items and the units. So I really want you to, practice the same thing. If you are doing this at the examination, do the perfect write-up. Even putting up zero here is also very important. Don't forget all this back with the table title, so on and so forth. Okay. Right. This is interesting. The last one, the pie charts. Nothing but a circle with a 360 representation. You're going to approximate the values for each slice. Okay. So each slice you're going to approximate and assign the number of degrees to be represented. This is used when a variable has multiple components and we want to easily visualize the relative importance of each component. Easy to understand what is the biggest one. Okay. What has happened to a component? Well, you have to put a couple of pie charts together for 2015, 2020, and maybe 2025, and then see what has happened to the relative contribution to a particular variable over time, likewise. So for one particular year or one particular instance, you can draw a pie chart, or for multiple particular instances also, you can draw different pie charts and put them in a aligning manner so that your viewer can understand what has happened to the components. Example to display relative contribution of each segment in export income of Sri Lanka during last year. So a pie chart would be perfectly uh, easy to understand as long as your pie chart doesn't have multiple components. Now let's say now this export income example. Okay, you can talk about um, IT services, agriculture, and then apparel, maybe fisheries, maybe those are the giants. But if you look at even those tiny items uh, like small crops, small handloom items, and there could be maybe hundreds and 200s of different items. In a pie chart, it's very difficult to represent everything. So that's why at the beginning I stress that sometimes in when you have multiple components, hundreds of components, a pie chart will always carry out the maybe top 10 or top maybe 5, and then the rest of the small items you can say other. Why do we do that? Because we at the pie chart we are trying to always represent the relative importance. That's a word to be highlighted here. Relative importance is what you're going to do, not the absolute numbers. If you really want to, represent the absolute numbers, you can still go for a bar chart. It's a perfect way to go, or a line chart for that matter. But here, this is where you are going to give the viewer what is the maximum, what is going to give me a 50%, what comprises of what is the top 10, what are the top 10 items of my contributing factors. So likewise, you could easily identify visually what the giants are or what the major numbers are going to be. I know for basic mathematics we have studied how to draw a pie chart, but still I just want to put this in case you have forgotten. Perfectly fine. A pi will be a circle which has 360 degrees. So like in our component percentage component example, we took the total and then we identify the relative percentage. To identify the number of degrees, all what you have to do is you do the same thing and multiply that by 3.6, which will give you the number of degrees to be included in the pie chart. For example, let's say 90 divided by 360 is going to be uh, sorry, 90 divided by 360 is going to be exactly 90 degrees. 25 divided by 100 is also going to be 90 degrees in the representation. So remember the fact that 360 degrees is the number of degrees allocated for a one pi. Importantly, when you're doing it, either we have to color it or do some shading or dots and um, any sort of a key which is comfortable for the viewer to understand what you're talking about. And also, if it is permittable, it's always good to put up an arrow and say this is the representation of the data set. Look at the pie chart in this example. 4 quarters, quarter number 1 to 4, sales revenue in rupees millions are been given here. 4.2 million, 3.6, 6.4, 10.2. Okay. And now we have to put things up here and give the contribution of each quarter that has come with these sales revenue. So to identify these numbers of 17%, 15%, 26% likewise, what we have to merely do is take the total here, 4.2 plus 3.6, addition of these items should give you a value of maybe 24.4, something like that. Take your calculator too. I really don't want to spend more time here. Just that number 4.2 divided by 24.4 is going to give the relative percentage of 17%. That multiplied by 3.6 will give you the exact slice, the number of degrees if you are drawing it in a visual manner. Now at the examination, students, now do you have to take a measuring device to do a perfect pie chart? If you may ask that, I would say not necessarily. If you have time, be my guest, perfectly fine. Do a perfect angling and draw it in the way. But as long as you know your relative representation, you do the slicing, and as long as you write the number, you don't have to write the number of degrees in a pie chart. That's not really necessary, but the percentage is pretty much enough. So if you even look at this first quarter and second quarter, first quarter has given 17% and second quarter has given 15%. Now, can one visually, measure this number of degrees and say, okay, this is correct or not? It's really difficult, isn't that so? So one could say, fine, as long as I draw two slices of approximately same size and put 17% and 15% at the examination level, this is perfectly enough. So at the row level, if you're using a pen and a paper, always find the relative percentage and multiply that by 3.6, which can give you the exact number of degrees. When you're using electronic software, you don't have to do anything. Just select all this data set and say draw a pie chart, then the system will do the math and do the drawing for you. Important points note. When you are representing a pie chart, either you have to have a key or some arrows with some text explaining what these individual items are going to be. Okay, that's on the pie chart, and nothing much more to discuss except the fact that keep in mind that a pie chart is sort of like a static representation. Now, in the previous instances, you may see representation of sales revenue for a couple of years, 2017, 2018, likewise. Okay. You can't add them everything up and say, okay, for the 5 years, this is my sales revenue representation in a pie chart. That doesn't really make any sense, isn't that so? What you have to do is draw a nice bar chart. 2017, this is the value. 2018, this is the value. Likewise, for the 5 years, you can say. But let's say that sales revenue has come from these quarters, and you really want to, instead of discussing from 2015 to 2020 for the full 5 years, sometimes in annual reports and these financial reports, you may see people comparing two different points using pie charts. That is, one in 2015 and the second in 2020. So in between, nothing. Why do we do that? So assuming that the trend has continued, with that assumption, one could identify from 2020's position after 5 years what has happened to this particular variables. Whether the fourth quarter revenue generator has been, has been there for last 5 years, or it seems to be a trend to have much more sales revenue in the fourth quarter. So instead, let's say you have 425% of sales revenue, each of 4.2, 4.2, 4.2, and 4.2 in 5 years ago, versus you have this pie chart that we see here. One could argue, okay, the fourth quarter sales revenue seems to be a trend that has happened over 5 years of time. So likewise, the pie chart, instead of a static point, sometimes you can take two pie charts side by side and discuss what has happened here. Some examination questions, you can see such kind of questioning and asking you to draw pie charts. Okay. Last but not least, I just want to stress here at the scatter diagrams. We shall be discussing this extensively in an upcoming class. Why the fact that we want to discuss in detail how the distributions are being converted into normal distributions and what sort of a value allocation can be done. Scatter diagram is nothing but you have the x-axis for a unlike sales revenue or a year or a different component, you have row numbers. So for a variable, sometimes for the independent variable and the dependent variable, the x-axis and y-axis can contain two values. So instead of you discuss values on only one individual x-axis and the frequency of that, instead for a small variable representation of 0.5, 2.1, 0.7, 2.6, 1.4, 0.25. A scatter diagram, a two-axis scatter diagram is a perfect way to represent such kind of data. But under variable analysis and standard normal distributions, we are going to identify why such kind of data are occurring, and for a given independent variable, how we can find the value of these dependent variables, and when you draw a scatter diagram, how to take that scatter to the next level. You are discussing extensively on identified trends, patterns, assigning a best fit line. So that is all sort of a next level discussion where we will spend more time over there. Okay. That's all about the discussion on theory today. And the last half an hour, we can spend time on the past paper discussion. Before we move on to that area, since we have a bit more time today, I can take a pause and see whether if you have any questions to be answered. If there's nothing, we can quickly move to the questions and we can finish off the class. But feel free to either use your microphone or the chat if you have any questions right now. So we'll move on with the questions and see what sort of angles being tested in the examination questions. Okay. Now, I've rarely seen MCQs being tested in this area. It doesn't really go to the extent on the examiner being focusing on very simple questions like what's the difference between a pie chart and a bar chart. That's not the style of questions in this paper. Rather, in the elective questions, sometimes for a 5 mark or at times for a 10 mark even, you may see data representation is being requested by your examiner. Okay. Let's discuss this question. Tourism Authority observes, this is 2019 September, question number 2. Let me just quickly see whether I have written the correct question. Yeah, 2019 September, question number 2. Tourism Authority observes following data on quarterly international tourist arrivals. X. Okay, X seems to be the value what you see here in this first row. X in 1000 seems to be the international tourist arrivals. For instance, if you read this first 604, that means 604,000 tourist arrivals in 2017 quarter number 1. Similarly, that's all about that. And the corresponding quarterly tourism revenue in both USD by million and in LKR is at billion during the period 2017 to 2019. Okay. So you have USD million revenue coming for this individual tourist arrival in the second row, Y variable, and Z variable the same on rupee. Don't forget the fact that when we are moving ahead with time, this ratio should be different. Otherwise, there's no point of writing the same thing in USD and LKR. So currency depreciation could be one reason for this. If you just take these ratios, obviously you can identify what the exchange rate is all about at these different points. Okay. The tourism revenue in LKR has been derived using the average USD LKR exchange rate prevailing during each quarter. That's exactly what we discussed. So average rate has been used to derive the LKR value. Right. Fine. The next table. The international tourist arrival by region in 2018 are given below. Middle East, Europe, so on and so forth. Fine. That is also in thousands. That means, for instance, if I discuss on this 291 of Middle East value is going to be 291,000 in number of persons from Middle East. Okay. So on and so forth. So 2018 data, they have again further given a different segregation that is coming from different geographical areas. Okay. Right. So construct a pie chart to present the first part I'm reading. Construct a pie chart to present the tourist arrival by region in 2018, indicating regions and corresponding percentage shares. Right. So if you look at the very first part of allocating 5 marks in this 2019 paper, all what you have to do is draw a small pie chart with the values that are shown in this table below. 291, 581. I'll just quickly take out the calculator and see the values. 291 plus 581 plus 872 plus 291 plus 291. Okay. You have 2326 as the total number of chaps that have arrived as tourists in this 2018. Let me quickly add up the quarter values and also see. Yeah, I get the same answer. That means these values of 700, 450, 575, and 600 is being approximately dispersed in these quarters Q1, Q2, Q3, and Q4 in this particular pattern of regions. Either, I mean, you can discuss from the quarters point of view, or for this whole year of 2018, you can discuss from the geographical point of view. Okay? So when you've been asked to draw the pie chart, there's no any specific computation except for the fact that you have to get the total here, total arrival here. I get the answer as 2326. Then take the relative percentage of individual items. For example, I have to take 291, 2325, yeah, 291. Let's discuss one, and I'll invite you to continue with the rest. 291 divided by 2325, that is a total that I see here, should give me an approximate number of 12% for Middle East. Similarly, if you take the fraction of 581, you will end up with maybe 25%, and 37% here, 13% here, and 13% here. So using those numbers, draw a simple circle, and whichever the method comfortable to you, even if you do it with a particular device for a circular uh, degree assignment, that's perfectly fine. But as long as just you put the small slices and put the number, that's perfectly fine. But you shouldn't do a small slice and say 75% or 100%, but the slices should be relatively uh, equal to the number that you are going to represent under each slice. That's it. Indicating the region and corresponding percentage of share. So for this whole 5 marks of this examination, this pie chart is going to give you the complete marks. That's about it. Look at the second part. Calculate the growth percentage change of tourist arrivals in 2019 Q1 and 2019 Q2 separately compared to the same quarters in 2018. That means 2019 Q1 and 2019 Q2. I have the arrivals still. I have tourist arrivals in 750 and 275. I just need to calculate the uh, growth of these numbers compared with the numbers of the same in 2018. That means the number of 700 and 450. Okay. If I just quickly try to use the board here for explanation. I have the values for 200 and 2018 and 2019 quarter one and quarter two as follows: 2018, 2019. Okay. 2018 quarter one is 700. Quarter one for 2019 is 750. 450 here for 2018 quarter two, and that has gone to 275 here. So this jump is what you need to identify. So this is nothing but 50 divided by 700 is going to give you approximately 7.1%. But here you see a decrease, isn't that so? What sort of a decrease? 25 to, yeah, sort of like 175 kind of a decrease. It's negative 175 divided by 450. Should give you approximately negative 38.9. Now these are the growths of this particular quarter. Now this is one important aspect of comparison. From quarter to quarter, what has happened to a particular value? Okay. So let me quickly come back to the question. If you visually see that again, 750 2019 has come from quarter one 700. 250 has decreased from 450. So what's this question is asking again? We'll see. Calculate the growth of tourist arrivals in 2019 Q1 and 2019 Q2 separately compared to the same of 2018 same quarters. So that those numbers 7.1 plus and 38.9 minus are going to be the uh, changes of the quarter on quarter. We call it quarter on quarter change for tourist arrival and quarter on quarter 2, 2018, 2019. Fine. Got the answer. Second point, draw a bar chart to compare quarterly tourist arrivals in 2018 and 2019. So absolutely simple exercise. What sort of a bar chart that you're going to draw here is sort of like a adjoining bars. I mean, you can do a component bar chart too, so that's perfectly fine. But as long as you have only 2 years, 2018 and 2019, you can do a multiple bar chart like this, 2018, 2019. Quarter wise, as in quarter one, quarter two, quarter three, quarter four. So I don't think that we have to, spend time on how to measure the height and do a bar chart. Hope you can get it managed. How many marks allocated here? I think 5 marks completely allocated for this particular part. Fairly straightforward, isn't that so? So don't get carried away. Now this is, we don't have questions on, the question. If you look at the next couple of parts, then you're talking about identifying a best fit line, do a regression. So uh, you won't get a question on, completely drawing and forgetting all this theory on statistics and score 20 marks. You won't get it like that. Maybe for maximum 5 to 10 of a marks could be seen from a subpart like this. I just want to stress the fact that by acquiring the knowledge on this lesson, what you should do is you should do a perfect job at the examination by doing a chart or a graph with the representation best practices that I taught you a moment ago. Naming, grading, scaling, even the key, numbering, axes, all has to be perfect for you to get the complete marks. Look at a different question. 2019 March, I have question number 3. Okay. This is, when I say question number 3, that means elective question number 3. This is on portfolio theory. You will learn this probably in the next 50% of our discussion on multiple asset class yielding multiple returns comprising of a portfolio of investments. If you glance through, this has treasury bonds, deposits with licensed commercial banks, registered finance companies. Now this portfolio of 120 million is giving me different returns. 11.5 for treasury bonds, a little lower, 13.4 commercial banks, and 14.5, a little bit higher, with a little bit higher risk in the registered finance company. So this seems to be a sensible return distribution. So there are different paths on the computation, but look at part number 3. I just want to highlight it here and show you what we're going to do. In order to compare the market value of this portfolio as at end 2018 and end February 2019, graphically present portfolio data in a component bar chart or a percentage component bar chart indicating asset classes. Okay. For you to do this question, I think we are still not at the pace of, we have to do a last bit of theory on portfolio, uh, or treasury bill bond calculation, because there's a write up here which says the value of this treasury bill, 364 treasury bill, as that particular date was 65 million with a price like 92.31. So when you do it, if I could remember correctly, we get a value close to either something like 60 million for this particular treasury bill portfolio as at 2018. So I don't really want to discuss the answer here, but I just want to stress the uh, theory that we learned so far. What do you need to do here for this 5 marks? It's a complete 5 mark question, part number 3. What you have to do is either do a component bar chart or a percentage component bar chart. Now, what are those? That means, let me quickly take you back. A chart like this or a chart like this to show the values of this particular portfolio. Now this is given as at 2018 end, and some more data given in part number 2 is going to give you the same numbers evolved to 2019 this particular point. One could do two pie charts and do the same, show what has happened to the values. But still, the examiner is specifically asking for this particular type. Be careful to draw the correct bar chart. That's what I stressed at the beginning of the class. These are pretty much simple stuff, but remember, the correct name, what is being called as what. Okay, let's see a couple of more questions. I have 2018 September. Question number 2. This is also an elective question. I hope you could recall our initial discussion of the examination paper. Depending on the past pattern, you can never say that the future is going to be the same as past, but hopefully, depending on the past pattern, we could guess that first question is going to be a compulsory, and there'll be some more questions as elective questions. So this part number 2, it's an elective questions. If you're comfortable with the question area, you can uh, do this, or you have choice of other questions. But be careful and see. I suggest whenever you see this graphical representation, although you may be not really comfortable with the question, bear in mind that the graphical representation part is very easy and very straightforward. So the maximum that you could do is like what we discussed, calculate the growth or the change for a particular number, what has happened to that number from quarter to year, get that number and draw. That's the maximum that you can go for the questioning. Otherwise, it's purely representing. So your keying, grading, and numbering is going to be the only thing that you need to know to get the full marks for the subparts. Okay. Look at this question. The company observes following data on annual advertising expenditure given in X variable in million Sri Lankan rupees. Right. It's 50 million, 70 million, likewise from 2019 to 2070. This top table is given like that. And why annual sales in million Sri Lankan rupees. Okay. So the norm should be, you spend more on advertising, you should get more sales revenue. And at the glimpse of this data set also, you can identify some similar pattern. So for 50 advertising expenses, you get a sales revenue of 150. But when you increase it significantly, 240, you get a higher sales revenue. Okay, we got a basic understanding on that. In 2018, now we are focusing on the next year, 2017, up until data is given here, 2018, we are focusing on. The expected advertising categories and corresponding amounts are given below. You have right. Now they are giving the total of 180 million. So this X value for this 2018 is going to be 180. Now they're giving the uh, individual components of this 180 million. You have school calendars, internet, newspapers, radio, TV, and sponsorship as the style or the mediums of advertising expenditure. First part. Complete 5 marks. First part. Construct a pie chart to present expected advertising cost in 2018, indicating advertising categories and corresponding percentage shares. What is the percentage for advertising on electronic media? That is on internet, radio, and TV. Students, now this is very straightforward. You don't have to worry at all. All what you have to do is 22.2 divided by 180, 22 point, now these are equal. This is 45. Okay, this seems to be double of this, and that is how this 180 is going to get comprised of. And draw a nice pie chart comprising of these elements of different advertising expenditures. So approximately 12%, 12%, 12%, and then 25% here, another 25%, and a 13% to total up to 100% shall give you the percentages. The last part is what is the percentage for advertising on electronic media. That means you have to identify what is electronic media, that is internet, radio, and TV. So you have 22.5, radio 45, and TV 45. Add these three numbers. You have a 12% and a 225% to be added here. 225% will give you 50. Add 12 or 13 as the way that you approximate it. Should give you either 62% or 63% as the answer for the latter question. That is the total advertising percentage on electronic media for 2018. Okay. Look at the third part. Again, in 2019, this company plans to double their advertising budget compared to 2018. 2019, okay, that means now we discussed this on 2018, is that so? Now 2019, the year after. 2019, double their advertising budget. Now, what is the percentage that, sorry, what is the absolute amount that we spent here? It's 180. This has to be now converted to 360 million in 2019. And further, there are some more. Stop advertising in school calendars and sponsorships. These two components will be gone. These 222.5 items will be gone. Further, it plans to spend 1/3 of total advertising budget on TV media. That means approximately 120. Isn't that so? 360 is going to be the double one. 1/3 is 1/3 of 360 on TV media. On absolute terms, that has to be 120 million. 1/3 on radio, another 120 million. And the balance equally shared between internet and newspapers. That means 60-60, 260s on internet and newspaper media. Draw a pie chart to present expected advertising cost in 2019, indicating advertising categories and corresponding percentage measures. Calculate the amount to be spent on advertising in newspapers 2019. Again, students, now this is, this is nothing but sort of like resolving small puzzles and doing another drawing. You have 180 here, you doubled it for 360, chop it off these two items. Then the question says 2 1/3. That means out of 360, 220 is going to be given for two categories. And what is remaining? Another 120 equally between newspaper and internet. Draw a nice pie chart and answer these questions. Okay. Fairly straightforward. Only disadvantage is you may have to spend a little time to do a precise drawing. But bear in mind, in 2018 September, if you answer this question easily, you could get a maximum of 10 marks by just answering these two parts. So that is why I want to stress upon during today's lesson that this doesn't really comprise of any big question as to you have one heap of data, then do a stem and leaf diagram, then why don't you do this and that. That doesn't really is a style of the examiner's appetite during the past examination, yes, but rather maybe 5 to 10 marks kind of a question coming from the representation part. That's the important part I want to highlight. The rest of the questions, I just want to show you quickly. Let's glance through them and see. 2018 March question number 2. Show the asset composition of the portfolio in a pie chart. So you have these values to be represented with the relative percentages. 2019 September, part number 2. Construct a pie chart to present asset structures of the portfolio, indicating asset classes and corresponding percentage of shares. Pretty much similar in that. So now you see a trend also. Whenever there's a portfolio theory question, we ask examiner is trying to put up some more testing on the data representation. 2017 March, bit of an old paper. Present these data in a component bar chart and a percentage component bar chart. Now this one you have to spend a little more time. You have 4 elements, carefully get the exact heights and the percentages and draw for the total of 2.5 marks. Isn't that so? Now this is just part number A of subpart number 2 of question number 6. So you have to be careful on spending time here. 17 March again. Similarly, portfolio theory question. Construct a pie chart to present asset structures of this portfolio, so on and so forth. 2016 September. Now this is a good question for you to try out and see whether you can find some creative answers. You have some advertising. First question is asking what is the percentage of share, so on and so forth. Do a pie chart. Second one, construct a bar chart to represent this data. Which graphical method do you think is the best to portray this data? What conclusions can you reach concerning how this company plans to spend the advertising funds in 2060? Now, this seems to be a lucky question where you could actually, score a good 20 marks on just by focusing on the representation of data. Last part is asking, compared in 2016. Now, from the percentages, you have the absolute numbers here. You have to, similar to the exercise that we do, one number convert into a different number, up or down. You have to calculate these new numbers for this individual items. For example, reduce spending on newspapers by 39%. That means newspaper you have 12.3 million. So the new value will be this multiplied by 61%. Why? You are reducing 39%. Similarly, this whole heap, if you read carefully, it's all about making up or down of these individual items and coming up with a new spending pattern for this particular year. Finally, again, construct a pie chart to present the data. Now, 2016 September seems to be a lucky year, if at all. You have to do a little math and do some more representation to get maybe good 20 out of 20 for this question. Okay, that's all for the day. It's merely a, I would say it's not a statistics oriented question rather, well, sorry, lesson rather, merely on the data representation and rather, how to answer this different question. I have one question here. Can you explain again 2019 September second question, how the growths are calculated? Yeah, I think I still have it on the board. The growth is nothing but you have one number that has exaggerated from the numbers previous. From 2019, if you look at this particular number of 750, I have taken 50 directly. That's because that the difference between these two numbers is the growth. When you want to calculate the growth of a particular number, easily what you have to do is take the difference and divide it by the initial number. So I have the growth of 50 divided by 700. But on this number, I have 275. So this seems to be a negative growth. So 275 minus 450, I should be getting negative 175. That divided by the initial number of 450 is going to give me this negative 38. So practice a little bit sums, a couple of more sums. You have that quarter on quarter example is going to be a good thing to practice couple of quarters and see what the growths are. Uh, this again, we will be practicing a little bit further on the modeling, financial modeling section also. We are having more of these computations. But just bear in mind that simply, if it is a number being grown, you have the last number, you have the first number, take the difference, divide by the first number, that should be the growth of that number. This is a classic example, it could be a positive growth and a negative growth also. Okay, if there are no further questions, you're welcome. If there are no further questions, we can wrap it up for the day. If you have any more questions categorically related to the examination questions, uh, you can just drop into my IPSL mail or drop me an email. I should be able to find an answer. But bear in mind that this section still, we are at the very light stage of the statistics and we do not have much more interesting calculation. The interesting numbers are yet to be come. So we'll spend more time on the examination paper. Sometimes we are spending entire days on the examination questions after a particular lesson. Why? We want to make yourself very comfortable at the examination. Okay then, stay safe and have a good evening.